welcome to another one of these Narrowboat Tech Talk series. That's number 2. Just getting through them. Hopefully that'll build up into a bit of an encyclopedia for, again, to improve people's learnings. They're not how-to videos, they are just to improve people's ideas and thoughts, processes, so you understand a bit more of the workings of a narrowboat. So we're building foundation work at the moment. We've already looked at Ohm's laws, got a really good feedback on that, so that's fantastic. Today I'm just going to look at series circuits, so components wired in series, and how that Ohm's laws applies to them and what the common functionalities are of a series circuit. The next one will be parallel circuits, which is a little bit more involved, a tiny bit, but not too bad. If you understand the Ohm's law, you can apply them to both of them. So series circuits, let's get started. Okay. Series circuits. What is a series circuit? Okay, so the video last time just showed one resistor, one thing in a circuit. So a series circuit is multiple, let's say, components connected, oddly enough, in series. What does in series mean? Well, imagine like a train or a necklace or something like that. So this would be the battery, okay? So that is a series circuit. A power source, a supply. So if you remember, the wide bar is the positive on the battery. This is a multi-cell battery, so some voltage. And then we're just using resistors at the moment. R1, R2, and R3. Okay? So what's in common in a series circuit? Well, the easy answer is current. So there is only one current because there is only one path. So the same current flows through R1, R2, R3, and then back to the batteries. So in a series circuit, the current is common, the same for every component in the circuit. The difference is the voltage is not common. Yeah, so you can see, if we put a voltage in here, let's say V equals 10, then that 10 volts doesn't appear here, or here, or here. If we put a meter in there, that V1 is across all of those resistors. Call that let's call that VT, V total maybe, or perhaps VS would be better, voltage supply. So I've changed that to VS. So VS does look like a 5, that does. VS is across all those 3 resistors. So across this resistor is V1. If you remember what V was, voltage, pressure. Across this resistor would be V2, and across this resistor would be V3. So how does that circuit balance? Well, quite easily really. VS equals V1 plus V2 plus V3. So the circuit balances, yeah? Right, hopefully you're with me so far. That is a simple series circuit with 3 resistors components in series. Again, the current is flowing from the positive plate through, sort of, convention says, the current is flowing from the positive plate through R1, through R2, through R3 and back. Okay, and because of the way they are wired in series, the voltages across each one will be different. So the pressure here is different to the pressure there and is different to the pressure there. So let's try and figure out what's going on, see if I can do an example and to try and understand what is happening in a circuit like this. Okay, so I'm going to drop down a little bit on my old knees. Let's do a bit of an example to see if we can make some sense of what's going on. So let's look at some values for R1, R2, R3. So we're going to go R1 equals 10 ohms, R2 equals 5 ohms, and R3 equals 20 ohms. Okay. So first thing, and we have a voltage of, let's say 100 volts. Just to try and make the numbers a little bit easier. Not sure they will be, but there we go. So let's figure out, firstly, with our Ohm's law that we did last time, we can figure out what the current is. Yeah, so the first thing we need to do is add up these three resistances. So RT, the total resistance, equals 10 plus 5 plus 20, which equals 35 ohms. Yeah. Now remember our Ohm's law from last week. Do you remember that from last week? Hopefully you do. VIR, we're looking for the current, so we're going to hide the current. So we have I equals V over R. Okay, we're looking for the current. I equals V, which is 100 divided by R, the total resistance, 35 ohms. And that equals, I need the calculator, so that equals 2.86 amps. So in this circuit up here, 2.86 amps is going through R1, through R2, through R3 and coming back. So that's part of the circuit we've solved there, right there, the current. What about these V1, V2, V3? We know from here that those voltages should add up to Vs, the supply, in our case 100 volts. So we can apply Ohm's law again in a different way to find out what these V1s are, V1, V2 and V3. So we're looking for V, so we cover V. So the equation we want is VIR. And that's like saying times there. So if we look at V1 equals I, which is a constant in this case, it's a series circuit, 2.86 times R1, 10. So V1 will equal 28.6 volts. V2 equals 2.86, the same currents flowing through, times 5. And V3 is again 2.86 times 20. What's a V2? 2.86 times 5 is 14.3 volts. And V3, 2.86 times 20 is 57.2 volts. So in theory, remember coming back up to the top, Vs equals V1 plus V2 plus V3. So in theory, if I've done my maths anything like, this should add up, in this case, to 100. 6, 7, 8, 9, 10, 11. 7, 11, 19, 20. And that's a 2. And there's 5, 6, 7, 8, 9, 10. So I've worked that out to 100.1 volts. Now this will always be a little different, only because these numbers, like the current was 2.85, you know, decimal places. But if I'd have worked it out to all those decimal, the further past the decimal point you include into the calculations, the more accurate that will be. But you can see now that that V1 plus V2 plus V3 equals V supply, and that's the proof right there. So that is as hard as a series circuit gets. That's as hard as a series circuit gets. As long as we know the supply, or two items, the supply voltage maybe and the resistances, or the other way around, we know the current and we know the supply, but we don't know what they were, we could always work backwards. So a series circuit, that's as hard as it is. Current is common, the voltage across the components isn't. Okay? The voltage across the components always adds up to the supply voltage. And the total resistance is easy. You just add the resistances together to give you the total resistance. Once you have those, you can apply Ohm's law very easily and solve that circuit. Okay, where do we see series circuits on a boat? Well, there might not be loads, but batteries might be wired in series. You could also, you could also see, I mean, a series circuit is, I'll put resistors in here, but a series circuit could be, focusing camera person, a series circuit could be a fuse, a switch, and a lamp. Now, even though these aren't loads, it is still a series circuit. So when we come to do things like fault finding and things, knowing how our series circuit works and the relationship between voltage, current, power allows you to test this kind of circuit and fault find on it. So again, this is the grassroots stuff. This is our foundations before we get on to things like fault finding, volt drops, volt differences, bad connections, all that kind of thing. So that's sort of it for series circuits. Hope you found that useful. I'll pop a couple of questions or put a couple of examples down in the comments box that you can probably try and work out based on three different resistances. I'll give you a few questions down the bottom, and then in a few days' time I'll add the answers into that comments as well. So I hope that was some use. Next time will be parallel circuits. They're a bit more, they're not more complicated, they just work in a different way. And once you've got that thing in your head, it's pretty straightforward. So we'll see you next time, guys. Thanks for watching. This is number 2, Narrowboat Tech Talk. And give us a thumbs up if you like that. Possibly press subscribe. Some of this stuff doesn't apply just to narrowboats. This applies to all electrics. But I will be focusing on the narrowboat world once we get some of this groundwork done. So thanks very much. See you next time. Bye.